Hello again, sixth grade learners. Here we're still talking about three-dimensional solids. Today we're going to focus on finding the surface area of a square pyramid. So no matter what three-dimensional shape that we've been talking about, rectangular prisms or cubes, maybe triangular prisms here, the idea has always been the same, is we're going to find the area of each of the faces on the figure. Okay, and find the area and then add them all together. And that total will give us the surface area, or the area of all the surfaces, all the faces on that three-dimensional shape. So those are some different examples we've looked at, but for today, we are going to be working on a rectangular pyramid. Okay, or in this case, it's a square pyramid. The base is exactly a square, right? And so we're going to do the same thing and take a look at a net. And to do that, I actually just printed off the same net twice. So you could get this idea again that a net is basically, if we unwrapped the shape, what would it look like? You know, and what would the flat surfaces each look like? And so for a square pyramid, we have a square base and then four triangles that make up the remaining faces. We call those the lateral faces. So again, you have the square base and then the four triangles that make up the lateral faces. So to find the surface area, all we're going to do is find the area of each of those four triangles, and then add that to the area of the square base. So on your assignment today, I have an example done for you. You're going to find the area of the four lateral faces, the triangles, and add that to the area of the square base. So finding one triangular face, we're going to go back to that formula for the area of a triangle, which is area equals base times height divided by 2, or area equals 1/2 times base times height, whichever one you prefer. In this case, the base of the triangle is 5 centimeters, and then the height of the triangle is that perpendicular distance again from the base to the vertex opposite of that base, which in this case is 6 centimeters. So 5 times 6 is 30, and then 30 divided by 2 is 15. So the area of one of these triangular faces is 15 square centimeters. Remember, there are four identical triangular faces. So I could take that number and multiply it by 4, and I get 60 square centimeters, which is the area of all four lateral faces. For the square, it's even easier this time because squares have congruent side lengths, right? So base times height is just going to be 5 times 5, which is 25 square centimeters. And so now I'm going to add in the area of those four lateral faces to that of the base. So here's the four triangular faces. Here's the base of 25. So I have a total of 85 square centimeters. Now I'll do one more with you from today's assignment real quick, just to show you the layout here. We have a square base with side lengths of 8. Here's that little right angle guy telling me that this dotted line here that's 10 inches is actually going to be the height of one of these triangles. So when we unfold the figure into its net, this is what it looks like. All right, and so I already started writing the formulas in here. It's really good to keep your work organized. So I have the formula, the area of a triangle is area equals base times height divided by 2. Again, instead of a b now for base, I'm going to plug in an 8. So area equals 8 times, the height of that triangle, any one of them is 10. So 8 times 10 divided by 2, which is 80. 8 times 10 is 80, so 80 divided by 2. And the area of one of these triangles is going to be 40, in this case, square inches. Okay? But again, this is the bonus of this, is all four of those lateral faces are the same size. So I can just very quickly do 40 times 4 and know that all four of those lateral sides, all four of those triangles together, are 160 square inches. Okay? Then I'll go over to the square, which in this case is 8 by 8. So I'm going to say the area of this square base is 8 times 8, or 64. Area equals 64 square inches. And now I'm going to take that and add it to the total area I had here for the four triangular sides. Let's see, that's 224, I believe. And so the total surface area is going to be 224 square inches. Okay, now I'll leave you guys to do this next example, and then on the last page on this assignment, again, I took away some of the nets. I'm asking you to draw those on this assignment, but really, by the time you start looking at a few of these, because it's a square pyramid, we know the base is a square, so all I have to do, and I'll do this without a ruler for the video here, but when you see my key, I'll have probably gone back and used a ruler to make a really nice square. All you have to do is make a square, and then you know the 4 remaining sides, just like when we unfolded the net, or in any of these other examples that you see, the 4 remaining sides are triangles that share that same base. So I'm just going to build a triangle off of each edge. And if you wanted to get real fancy, you know that this slant height here of the pyramid again matches up with the height of any one of these triangles. So you could draw in this little right angle guy. When you start labeling your pieces, you know that this is 8 centimeters because it's showing that is our slant height here. And you know that any one of these side lengths are 5 centimeters. So you could label as many of them as you want, and then go ahead and get back to your calculations of the area for the triangles and the area for the square base, and then add them all together. So by now that we've practiced with rectangular prisms and triangular prisms, this square pyramid should actually be kind of a breeze because of some of the shortcuts that we're able to take, and it makes a little sense, a little easier to unfold in my mind when you're looking at the net. So good luck with this assignment, and again, keep checking Google Classroom for updates, and make sure you get on for your numeracy routine on our WebEx Teams app. All right, have a great day.